Let's do this. So I guess, well, maybe I should ask before we get rolling. Were there questions so far on assignment 34? That was the sigma notation assignment from Friday. Because where we're going with this, the rest of 4.2 uses sigma notation as well as 4.3, actually a pretty big idea in calculus, uses sigma notation. Yep. So we're still really in 4.2. We started 4.2 Friday. I think we called it 4.2 back then. Finding the slope of a curve at a given point was kind of the big idea for first semester. A derivative will do that for you.
Yep.
Finding area under a curve is really the big idea for second semester. And when I say under a curve, I mean under the curve and above the x-axis. Sometimes you don't even need calculus to do this. If the curve isn't really so much a curve as it is like, you know, a line. So an example here. If we want to find the area below y equals 1/2 x squared plus 1 on the interval 0, 3. We can actually do that without doing any calculus. Because the quote-unquote curve that we're dealing with isn't really a curve, it's a line. And so what we're going to get when we graph this is a nice geometric shape. We can use geometry formulas to find the area. Maybe a quick sketch is in order. If our interval is 0 to 3, we'll concern ourselves with those kind of x values. Not to sound condescending, those kind of x values. That's not what I mean at all. If we plug in 0, what do you get for y? Plug in 0 for x. 1. All right. So we're going through 0, 1. If you plug in 1, you get kind of icky stuff. Let's just plug in 3. We know it's going to be a stupid line anyway. Let's plug in 3. Square it and you get what? 9. Cut it in half and you get 4.5. Add 1 and you get 5.5. All right, so this is 1, 2, 3, 4. Bad planning. Bad planning. There, whatever. So the shape that we're trying to find the area of is the stuff below this line segment, bounded by 0 and 3. That's the whole on the interval 0 to 3. Means where do you slice it on the left and where do you slice it off on the right. And then saying below the graph also means above the x-axis. So this is our shape that we're trying to find the area of. And we can actually, like, yeah, we can do this without calculus. Any ideas how we can do this? Split it up into two shapes, yeah? Certainly. All right, yeah. You can do, there's a rectangle along the bottom here. Easy to find the area of a rectangle. It's sitting underneath a triangle, which frankly isn't very difficult to find the area of either. So I'm going to call this area 1 and area 2. I'm glad there's only these two. Once I had a problem with I had to break it into like 55 parts, and no one could find Area 51. That problem was from out of this world, let me tell you. All right, so area 1 is a triangle. Its area formula is half base height. So half times, what's the base of that triangle? 3 units, yeah. And the height, let's see, this is what, 5? This is 5.5, but it starts at 1. So the height's actually this minus this is 4.5. That works for everyone? So, gosh, 3 halves times 9 halves would be 27/4, yeah?
Sure.
Label's not really going to be ultra super important, unless they give you a story problem where the area represents something. If they just say, hey, here's a graph, what's the area under it? You don't have to put like 27/4 graph paper squares squared or something. Yeah, it's not that cool. But we still have to find area 2. That's just a what by what rectangle.
1 by 3.
Yeah, 1 by 3, so that's obviously 3 units. So 27/4 plus this is 12/4. 39/4. So your total area then would be 39/4, 9 3/4. What's that?
Watch the movies? That's annoying, man. That's it.
We all right on that one? Where we're going with this is eventually we're going to be finding areas beneath curves that aren't linear. So they won't be like what they call polygon shapes. They'll be, literally curves, wavy things. So areas below curves that do not form polygons are more difficult to calculate. In fact, without calculus, you can't even get a dead-on value. Using this Algebra 2/geometry method, you can get a good approximation for the areas below curves, which is what we're going to be doing today and tomorrow before we talk about how to get the actual dead-on answers.
Couldn't be more excited.
Yeah. So what we're going to do for today, as an example, is estimate the area. Below y equals 6 minus x squared. On 0 to 2. And what we're going to do to accomplish this, we're going to draw in a bunch of rectangles. And we're going to just find the area of the rectangles and add them all up. Okay. So what they're saying here is they're going to tell us to use 4 rectangles. So pictures are going to be kind of useful in these problems.
How do you spell rectangle?